What's the biggest number that you can think of? A Google? A Googleplex? No matter how big a number you can see, there's always the next higher one. It's quite difficult to comprehend when it comes to extremes as grand as these. This brings me to the topic of infinity. Infinity is so big that it isn't actually a number, but rather a special type of number, since all real numbers are needed to form it. When a number shows how many things there are, then it is called a cardinal number. For example, 3 bananas or 72 ostrich feathers. The cardinality of the set of ostrich feathers would be 72, as an example. When we talk in terms of the infinite, it is more useful to speak relatively rather than absolutely. For example, let's imagine that we have two boxes. One's filled with diamonds and the other is filled with safes. Our goal is to see if there are equal amounts of each item in each box. Now, sure, you can count each one by one till there are none left, but an alternative way, a way to help us picture the infinity, is remove a diamond, remove a safe, and then put the diamond in the safe, and do this until there's none left. If both boxes run out of their respected items at the same time, then we can safely say that they have a one-to-one correspondence with each other. A similar example would be like saying, I have 5 fingers on my right hand. You don't say there's 5 fingers on your right hand, but rather you say, there are just as many fingers on my right hand as my left hand. Capiche? Interestingly enough, there are different sizes of infinity. The smallest is countable infinity, like how many hours are in forever, or all the whole numbers. And the other kind is uncountable infinity, which is like saying how many fractions are there between 0 and 1. We can't even get to 1 because you can always just go smaller in its own sense. When we think of sets of numbers, the first one that really comes to mind is a set of all natural numbers. And to represent all natural numbers infinitely, we would use a special character known as Aleph Null. Now, this represents all numbers, odd, even, and even every fraction in between all of those, all in one symbol. It's impossible to count to, yet it is possible to go even bigger. If we consider Aleph Null to be its own set, we can represent it with this illustration of lines, with each line decreasing in length but never actually disappearing. So if we draw a line over here, what number would it be? Aleph Null plus 1? Not quite. We can't add natural numbers to a set containing all natural numbers. To find order in the realm of infinity, we wouldn't want to count like we've been doing our whole lives, but rather rationally organize. To do this, we would use ordinal numbers. These are values that don't abide to how many there are, but rather the order in which they came. To count past Aleph Null, we would use the Greek letter omega. It represents the first value that comes after an infinite set. If you get omega'th place in a foot race, then it means that infinitely many runners finished before you did. As long as the set is ordered, it doesn't matter how vast the amount is. There can always be new numbers reached. With that being said, these don't mean that ordinals are necessarily bigger than cardinals, just that they come after them. It's something important to realize. If we want to make bigger numbers, what we would do is use power sets. A power set is The power set of a set is all the possible subsets that can be made from it. So for example, if we do the power set of 1, 2, and 3, all the possible outcomes are 0, 1, 2, 3, 1, 2, 1, 3, 2, 3, and 1, 2, 3. Things get really crazy if we put Aleph null in a power set, meaning all combinations of all amounts of all natural numbers. We can even put that power set into another power set, or into even another one, creating exponentially more amounts of combinations of numbers that were not previously there. One other thing to keep in mind is that the concept of infinity is something created from nothing but the human imagination, abiding by axioms set by other humans. So the question is, are we inventing this stuff or discovering it? Who's to say? Much of this is theoretical, but referring to the axiom of infinity, it declares that at least one infinite set exists, the set of all natural numbers. Another axiom that can be applied is the axiom of replacement, which states that previously achieved numbers can be used to create even bigger ones. If we use this principle, then it allows for bigger and more numerous jumps than before, creating a wildly accelerating feedback loop of immense numbers. We've been able to explore and create unfathomable numbers, but when compared to uncountable infinity, it hardly makes a dent. Any finite amount, plus times or exponentially expanded, only creates more finite amounts. Infinity is impossible to reach from below. It's inaccessible, something that exists only in the mind of the thinker. Their existence is declared axiomatically as it is yet to be observed in our physical universe. If we can one day in the future put these infinite concepts to use, then great. But if not, still great. We managed to understand something that exists outside of our physical domain with our own tiny brains. Something that's just never ending and so impossible to wrap your head around. It's not that bad.